Hello everyone. In this video, we're going to look at some operations that we can do on matrices. So we're going to go over equality. So when are two matrices equal? We're going to look at matrix addition. So how can you add two matrices? Also, we're going to look at matrix subtraction. How can you subtract two matrices? And also, finally, how can you multiply a matrix by a number called scalar matrix multiplication? All right, first up is equality. This is very standard in mathematics. When you introduce new objects, you want to be able to compare these new objects and define the notion of when are they equal or equivalent. So for matrices, what is the definition of equality? So two matrices, A and B, are considered equal, and this is going to be denoted by E equal B using the obviously equality symbol when the two following conditions are satisfied. First up, A and B must have the same size. So A and B must have the same number of rows and the same number of columns. If they have different format, they cannot be equal. Even if they look alike, not the same number of rows or not the same number of columns, no, it's not going to be enough for equality. And the second thing is when they have the same size, all their entries in their respective position must be equal. So if you have M as the number of rows and N as the number of columns, then the entry of A must be equal to the entry of B for all rows and all columns. Let's look at an example. So let's find, if possible, values of x such that A is equal to B or A is equal to C. So let's do A first. So we see that both A and B are 2 by 2 matrices. So they have the same size, so they at least satisfy this first condition. But are they equal? Well, I see that 2 is equal to 2, first row, first column. 1 is equal to 1, first row, second column. 3 is equal to 3, second row, first column. And I need to figure out what is the x such that it's equal to 5 in the second row, second column. Then obviously, boom, x needs to be equal to 5. If x is anything else, these two matrices are not equal. So A and B are equal because they have the same size, and this is only possible when x is equal to 5. Next up, if we look at A equal to C, is that possible? Even if 2 is equal to 2 and 1 is equal to 1 and 3 is equal to 3 and maybe x could be equal to 4, the problem is that there's an extra column in matrix C. Matrix A is a 2 by 2. Matrix C is a 2 by 3. They don't have the same size, so you don't have to even bother looking at the entries. So here, because they are different format, they cannot be equal. So this is typically the first thing you do. Check the size. If they don't have the same size, they are not equal. All right, the next operations are addition and subtraction. So how do you add matrices together and how do you subtract matrices? So here's the definition. Suppose A and B are two matrices, and suppose that these matrices, they have the same size. So suppose they are M by N matrices. And let's say that Aij are the entries of matrix A and Bij's are the entries of matrix B. So remember the notation for Aij, it means the entry on the ith row jth column, and same thing for Bij. So the first operation is addition. So the sum of A and B is going to be a matrix that is going to be again a M by N matrix, and the entry on the ith row and jth column is simply going to be the sum of the entries of A and B. So on the ith row jth column, the entry is Aij plus Bij. The next operation is the difference between A and B. So the difference of the matrix A and B is going to be again a M by N matrix where the entry on the ith row and jth column is now going to be the difference between Aij and Bij. So just subtract their entries in their respective position. One thing that is important is that when those matrices A and B do not have the same dimensions because they don't have the same rows, the same number of rows, or the same number of columns, then these operations are undefined. And this is something very typical in linear algebra class, that we give you operations where at some point they are not defined, and you need to be able to argue correctly that the sum or the difference does not exist or is undefined because they don't have the same size. So size does matter. So these operations are not too complex. Just make sure they have the same size. And if they are sharing the same dimensions, then just add the entries or subtract the entries. So let's do some examples. Let's say we have here matrices A, B, and C. You can see that the first matrix is a 3 by 4. The second one, B, is also 3 by 4. But the matrix C is a 2 by 2. And we want to compute A plus B, A minus B, A plus C, B plus C, A minus C, and B minus C. It looks like this is a lot of operations, but we will see very quickly that most of them are undefined anyways. So again, just like I said, A and B are matrices of the same dimension, but C is a matrix that is a 2 by 2 matrix, which means that every time you're trying to add A with C or B with C, or same thing for the difference, that operation is automatically undefined. So A plus C, B plus C, A minus C, B minus C, all those matrices are undefined. So let's do the other two that are actually defined. All right, so for A plus B, both matrices have the same size. So let's go. Let's just add these entries in their respective position. So 2 plus minus 4, 1 plus 3, 0 plus 5, 3 plus 1, and that's it for the first row. And then again, minus 1 plus 2, 0 plus 2, 2 plus 0, and 4 plus minus 1. And then finally for the last row, 4 plus 3 minus 2 plus 2, 7 plus minus 4, and 0 plus 5. And then if you do the computations correctly, you can verify that the final answer is on the first row, minus 2, minus plus 4, 5, 4, 1, 2, 2, 3, 7, 0, 3, and 5. That's the result of adding all the entries in their respective positions. For the subtraction of A minus B, you put the numbers in the exact same spot, but the only difference is instead of adding, you're simply going to be subtracting. So here you see now I have like a minus between the entries, and I just do my operation. And that as you compute everything, for example, 2 minus 4, you're going to get 6. 1 minus 3 minus 2, 0 minus 5 minus 5, 3 minus 1 is 2, 1 minus 1 minus 2 is minus 3, 0 minus 2 minus 2, 2 minus 0, 2, 4 minus minus 1 is 5, 3 minus 4 is 1, 2 minus 2 is minus 4, 7 minus minus 4 is 11, and 0 minus 5 is minus 5. That's it. So just be careful, do all the operations carefully, adding and subtracting matrices, not too challenging. Just make sure, of course, first and foremost, that these boxes have the same size. If not, the operation is undefined. The next operation is scalar multiplication. For that specific operation, we're going to be multiplying a matrix, a m by n matrix, by a scalar or a number. So for scalar multiplication, we start with a matrix. That matrix is a m by n. And actually here, the size does not matter. So you start with a matrix and a number or a scalar k. Then the scalar multiplication is the matrix k times a, is simply the matrix that is obtained by multiplying every single entry. So every single entry of the matrix A is going to be multiplied by K. And that matrix Ka is said to be the scalar multiple of A. So Ka is the scalar multiple of A. That operation is always defined. Okay, so you cannot have a number multiplying a matrix and the result being undefined, because here the idea is that if you multiply, for example, a matrix by 2, you simply multiply all the entries by 2, and that operation is always going to work. Let's look at some examples together. So we have three matrices here, A, B, and C, and we want to compute 2 times A minus 1 times B and 1/3 times C. So here we go. So I wrote right away for you 2A minus 1B. So sorry, 2A minus 1B and 1/3 C. If you are doing all the operation in detail, you simply are putting the scalar in front of those matrices, and then the only thing you have to do is distribute the scalar inside these matrices. So the 2 goes inside the matrix A, the minus 1 goes inside the matrix B, and the 1/3 goes inside the matrix C. And then if you do the actual computations for the final result, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 1 is 2, 2 times 3 is 6, 2 times 1 is 2. So nothing too difficult, just multiplying by 2 everywhere. If you multiply everything by minus 1, basically what you're doing is changing the sign of your matrix. So 0 goes to 0, 2 goes to minus 2, 7 goes to minus 7, minus 1 goes to plus 1, 3 goes to minus 3, and minus 5 goes to 5. And then for the last one, what a coincidence. All these entries were actually multiple of 3. So if you multiply 9 by 1/3, or if you're dividing by 3, you're getting 3. Minus 6 divided by 3, minus 2. 3 divided by 3 is 1. 3 divided by 3 is again 1. 0 divided by 3 is a nice 0. And then 12 divided by 3 is 4. So for scalar multiplication, just take your time, multiply throughout. So the size of the result, you see here, these matrices are not changing sign when your size, when you multiply 2 with A, you're not getting something twice as big. It's still a 2 by 3 matrix, but the entries got double. So the size does not change. The operation is always defined. So on the ith j column, the entry aij will become k times aij. All right, that's probably too much information, but it's a very simple and nice operation. Now let's do an example where we combine more than one operation. So suppose we have this matrix A, a 3 by 4, and B, another 3 by 4, and we want to compute C, which is A plus 2 times B. So here, if you have scalar multiplication, always do the scalar multiplication first. So we're going to be computing 2 times B first. And then once we have that result computed, we're going to add to that matrix 2B, the matrix A. So here we go, just take your time. So what is A plus 2B? So you see here, I'm taking the matrix B and I'm multiplying it by 2. So I'm putting a 2 in front of it. And now I'm just multiplying by 2 everywhere. 2 times 2 gives me 4. 2 times 2 gives me 4. 2 times 2 gives me 4. Minus 1 times 2 is minus 2. Minus 3 times 2 is minus 6. 1 times 2 is 2. Minus 5 times 2 is minus 10. 2 times 2 is 4. 2 times 2 is 4, minus 4 times 2 is minus 8, 5 times 2 is 10, and minus 2 times 2 is minus 4. Again, you can do these things in one shot. You don't have to do these computations individually, as long as you do them correctly. And then you're going to be adding those two matrices. So 1 plus 4, that's my first entry, minus 1 plus 4 is my second one on the first row here, 3 plus 4, that's first row, third column, 1 minus 2 is my last entry on my first row, and etc. I'm not going to just spell out all these computation. If you actually do these computation, 1 plus 4 is 5, minus 1 plus 4 is 3, 3 plus 4 is 7, 1 minus 2 is minus 1. And of course, when you're doing these operations on paper, if you can do right away 1 plus 2 times 2 and you get your 5 right away, good for you. So try to do these operations as fast as you can, but just take your time. Matrix operations are typically not too difficult to compute, but because there's a lot of numbers around in these boxes, it's also very easy to make small, silly mistakes. All right, so for this video about checking when are two matrices equal, how do you add two matrices, how do you subtract two matrices, and how do you multiply a matrix by a number? That's it. That's all. Bye-bye. Let me just finish my heart. Just said bye-bye before my picture. All right, bye-bye.